So a computer language. So what is a computer language then? A computer language is the is a computer language or programming language, a set of rules called as syntax, which which the user has to follow to instruct the computer what operation he is going to perform. So what is a computer language then? A computer language is a kind of a syntax or rules how what a user must follow. Like a college, if we speak about a college, we people set some of the rules how a student must be there. Same way, a computer language is being used. Same way, a computer language is being used for the process or performance of the given system. Performance of the given system. How actually it is, we should perform data or we should perform operations. Okay, so that is what a computer language is. A language is a medium of communication. As you all know, when we speak with the data or when we speak with a person, what we do, we share some kinds of things through a language itself, right? When you speak to a person or when you speak to a friend, you're going to speak with your own preferred language, which means that you're going to translate, you're going to speak to a system, right? Same way two persons here, we speak to a computer for our works, for our satisfactory work. Okay, so we have to communicate with the computers. We require a suitable languages. Whenever we require to communicate with a system or a computer, we require suitable languages. So, okay, suitable languages. We require suitable languages to understand their computer. Such language are called as programming language or a computer language. What language a system understands? Such languages are called as programming language or a language transistors. Programming language or a language transistors. Okay. So now, so there are in a computer, we have different kinds of programming languages. One is two types, they have converted into two types. One is low level language and high level language. So what is a low level language then? A low level language is a system language. It is not a system language. Okay. So where there is no intermediator or a translator, it is directly communicated to a system. That is a low level language. Then what is the high level language then? High level language has a transistors, or we use this high level language in our general English like terms. General English like terms. Okay, there are two types of languages, a low level language and high level language. When we speak about a low level language, we have two kinds of things. One is one is machine level language and other one is assembly level language. Okay, one is machine level language and other one is assembly level language. When we speak about terms of higher level language, where a user is going to perform some of the action, then we have two types of things. One is special purpose language and general purpose language. One is special purpose language and general purpose language. So let us see one by one what are those. Okay, first one is machine level language. So what is a machine level language? A machine level language is an independent language. When I speak about a machine level language, what I'm going to say is a machine level language is a independent language. Why means? Because whenever you are going to work on a system, whenever you are going to work on a system, you are going to find different kinds of operations. Okay, those operations are done for the optical things, right, for optical things, for optical things. Okay, so what is a machine level language? Means we speak on a machine level language. It is a, you see, it is a machine independent language. Machine independent ಅಂದ್ರೆ ಏನು? ಬರೀ ಒಂದು ಸಿಸ್ಟಮ್, ಈಗ ನಾನೀಗ ನನ್ನ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಏನಾದ್ರು ಕೋಡ್ ಮಾಡಿದ್ರೆ ನನ್ನ ಸಿಸ್ಟಮ್ ಮಾತ್ರ ಆ ಕೋಡ್ ಇರೋದು, ಅದನ್ನ ನಾವು ಏನು ಅಂತ ಕರಿತೀವಿ? ಮೆಷಿನ್ ಇಂಡಿಪೆಂಡೆಂಟ್ ಲ್ಯಾಂಗ್ವೇಜ್. Okay, what now? Let us see what is this machine level language. Machine level language, this is the one of the only language of a system. Only language system ಅಂತ ಹೇಳಿದ್ರೆ ನಿಮ್ಮ ಸಿಸ್ಟಮ್ ಏನ್ ಅರ್ಥ ಆಗ್ತದೆ ಅದು ಮೆಷಿನ್ ಲೆವೆಲ್ ಲ್ಯಾಂಗ್ವೇಜ್ ಮಾತ್ರ. So the instructions which are given is will be given in zeros and ones. So as you all know, your machine only knows zeros and ones called as binary level coding. So this binary level coding are been set as a voltage. If zero means low, one means high voltage. As zero means low and one means high. This is the fastest because there is no middleman to convert. So for example, if you require to speak with some person, like for example, one person knows only Malayalam language and other person knows only a Kannada language. Okay, so the what I speak, I will speak in English. So one person what he does, he will translate both Malayalam person also and for a Kannada person also, which means that he is a translator or he is a middleman between the two systems. But when a person who knows Malayalam itself, we can directly communicate with Malayalam itself, right? Or he knows the Kannada means he directly can communicate with Kannada itself. Correct? Same way, this machine level language directly communicates with the system without any interference or without any translation or transferations. Okay, or transistor or a middleman. Okay, so it is directly going to speak with the system. So this is very difficult to debug. Why it is very difficult to debug means we always use zeros and ones. Okay, so whenever we are going to use zeros and ones, we doesn't know, or we get bit difficulty to work on a system. Means ನಮಗೆ ಎಲ್ಲ zeros and ones ನಾವು ಯೋಚನೆ ಮಾಡ್ಕೊಳ್ಳೋಕೆ ಆಗೋದಿಲ್ಲ. For this reason, this becomes very difficult. This program is only done with the help of experts. He should be very experienced in the internal architecture. Only then he can work for a given system. If he is very intelligent or he is very experienced, only then he can work for machine level language. By using this language, we can use each and every bit of space. So namige space. Now we will not lose our space. What we can speak here is we are not going to lose our space any bit also. Okay. So now let us see some of the advantages, and disadvantages. So what is the advantage? Main advantage here is the instructions are here directly typed and executed. There is due to there is no middleman over here, we can directly type and execute our language, execute our code. Okay, no compiler or translator required because as we all use this, as we all directly work on a zeros and ones concept, here a translator is not required. Okay, there is no requirements of a translators. So okay, what is the disadvantage of this program? Here this is a machine independent. ಒಂದೇ ಒಂದು system ಆ program use ಮಾಡಬಹುದು. Multiple systems ಆ program ನ use ಮಾಡಕ್ಕಾಗಲ್ಲ. That is known as machine independent. Okay, machine dependent. Okay, it is very difficult to program and modify. Difficult to program, modify, and debug the errors. So whenever you are going to use a machine level languages, it becomes very difficult to modify, debug a program or an error. So this is the disadvantage. Now, how a machine level language looks actually? A machine level language looks as similar as this. So anything if you want to work, it is going to use zeros and ones language itself, or it is going to use a high level three types of decimal standards. One is binary, decimal, hexadecimal, and octal format. So these are things are being used in a machine level coding. These are things are being used in a machine level coding. Understood? This is what a machine level language is. So next is assembly level language. So why a assembly level language is being used? Mainly a assembly level language is being used to overcome the drawback of a high level languages. Sorry, drawback of machine level language. Okay, so assembly level language has been used to overcome the drawback of machine level language. What is the drawback of machine level language? The drawback of machine level language is each and every codes are not concentrated, or we can say each and every programs are not being set. Like if I need to say andre nanige aa ella code ಯೋಚನೆ ಇಟ್ಕೊಳ್ಳೋಕೆ ಆಗೋದಿಲ್ಲ. Next is it is machine dependent. Well, this is machine dependent code. Here all the codes are not being memorized. For this reason, that is a drawback of a machine level code. Here they came up with one more concept called as assembly level coding, which eradicated the drawback of a machine level code. It uses a symbolic instruction called as assembly languages. So symbolic instructions, let's say for the example, if you need to add two numbers, it gives a code called as add. Multiply means mult, delete means del, or to load means allow ad load. So like that they ಅವ್ರು ಏನ್ ಮಾಡ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ ಎಲ್ಲಾ ಒಂದು ಡೇಟಾಸ್ ಎಲ್ಲಾ ಒಂದು ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಗೆ ಅದರದೇ ಆದ ಒಂದು ಕೋಡಿಂಗ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಮೇಂಟೈನ್ ಮಾಡ್ತಾರೆ. That coding standard is known as a assembly language. This symbolic coding language, what I said, a coding language, is referred as mnemonics. The symbolic coding language is referred as mnemonics. A mnemonics is mnemonics means the symbolic instruction codes of a assembly level language are referred as mnemonics. Symbolic instruction coded of assembly level languages are known as mnemonics. Okay, this symbol is represented as mnemonics, and the process of debugging is carried out through a translator called as assembler. So ಇಲ್ಲಿಗೆ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿಗೆ ಒಬ್ಬ ಮಿಡಲ್ ಮ್ಯಾನ್ ಬರ್ತಾನೆ. So to convert a assembly level coding into a machine level coding ಗೆ ಒಬ್ಬ ಮಿಡಲ್ ಮ್ಯಾನ್ ಇರ್ತಾನೆ. That middleman, the name of that middleman is known as assembler. So now let us see the advantage and disadvantage of the assembly level coding. So the main advantage of the assembly level coding is here we can easily remember the codings, and it is very easy to debug. Why we can easily remember the codings? Because we are not going to work on zeros and ones. We are not going to work on zeros and ones. Hence, we can easily remember the code, and due to for this reason, if we are not going to use zeros and ones for this, we can easily debug that code. For this reason, we can easily debug that code. Okay. So what is disorder then? So this is also a machine dependent code, and when we deploy a code, when we write a code, for example, if I need to add two numbers and I'm going to write a code for that, here to deploy a code, it takes a lengthy process, like 10 to 15 lines or 10 to 100 lines or 1000 lines of code. So for this reason, this is very difficult to deploy the code. So this is what assembly level coding. So what is assembly level languages? Assembly level languages uses the symbolic instruction called as assembly language, which is known as mnemonics. This is what assembly coding. So now let's see how assembly level coding looks like. So assembly level coding, so the mainly assembly level coding looks like this. Load R1 X means it is going to load a one program to the X value, one more program loader to the Y value. Multiply both R1, R2, and R3. Mult means used to multiply. Add means it is used to add three numbers. So this is how a assembly level coding looks like. So this is what assembly level coding is. The next concept is high level language. So this is the day-to-day life language which you are going to use in our computer sessions. So what is the high level language? This language is came to overcome the drawback of both machine level language and assembly level language. So as we all know, both the machine level language and assembly level language are language independent. So which means that once if you're going to use this in a system, then you can't take it back. That is what assembly level and machine level coding do. But here this language becomes the machine dependent code and uses English like statements. So any person can easily read out the statement and easily debug the statement. Okay. Next, the main work is to use the problem statement. Here, always a high level language concentrates on a problem statement, not on the system configuration. When we speak about the high level languages, here the language will only deal with the problem statement. Yav tara problem ide, yav tara scenario ide. A scenario na ನಾನು ಹೇಗೆ ಸಾಲ್ವ್ ಮಾಡಬಹುದು ಅಂತ ಹೇಳೋದು ಥಿಂಕ್ ಮಾಡ್ತಾ ಹೊರತು it is not going to think on a details of the system, how a system is, how much camera it is there. It is not going to think on that. It is only going to see what is the problem statement, how I can resolve that problem statement, and so on. So some of the high level languages are BASIC, COBOL, Fortran, Pascal, C, C++, Java. Nowadays, Android and many kinds of the software has been already reached the high level language code. Okay. So the next advantage and disadvantage. So what is the advantage of the high level language? And the advantage of high level language is that it is a machine independent. Main advantage is it is a machine independent. So independent andre ಏನು, ನೀನು ಒಂದ್ಸಲ ನಿನ್ ಪ್ರೋಗ್ರಾಮ್ ನಿನ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಕ್ರಿಯೇಟ್ ಮಾಡಿದ್ರೆ ಬೇರೆ ಸಿಸ್ಟಮ್ ತಗೊಂಡೋಗಿ ಹಾಕಿದ್ರು ಅದು ವರ್ಕ್ ಆಗುತ್ತೆ. That is known as machine independent code. Okay, it is very easy to learn and understand. So if you have a knowledge of that If you have a basic knowledge of that concept, it is very easy to understand a given structure. It only requires a knowledge of internal structure, how a syntax has have been written. That syntax, if you know, it is very easy. These things you are going to use in your programming level, like in using when you are going to create a C++ language, you are going to use this programming coding using a high level language itself. Okay, so it is very easy to debug and modify. It is very easy to debug and modify. So what is the disadvantage? A disadvantage here is it lacks in flexibility. So what happens here is when there is lots of codes, if you have multiple lines of codes like 200 or 500 lines of codes, it will lose its flexibility, and here the programmer will not be a part of this. Then a programmer only has the option to work on a things, but not on a given pattern. Andre, so the high level language lacks a flexibility because the feature of high level language always occurs and are not under the control of a programmer. So what happens here is a programmer work he will use to write a program. But if the that software has evolved, or if many things got evolved, the programmer will not be in a phase to fix that. He need to do a newer thing. That is the one of the disadvantage of the higher language. Next, it is very slow in execution because here, as I always speak, as I already spoke about assembler as a middleman, here you all know that system only knows zeros and ones. So what happens here is whenever this zeros and ones has to be this higher level language has to be converted into zeros and ones. So to convert the zeros and ones, we use a transistors. So those transistors will convert your high level language into a machine level language. For this reason, this is very slow in execution. It requires it requires a middleman to convert the statement. So now let us see how wait a second, how actually a high level language looks like. So you can see, I'm going to open my Word and I'm going to show you how a high level language looks like. So this is how a high level language looks like. So you can see out here. So why it is very easy to understand? Because we are going to use some of the codes. This is the C++ coding level. Okay. This is how a high level language looks like. So any kinds of things we are going to use a English like statements itself. So for this reason, the person can easily read out what a problem statement is. Okay. So here, this is how a high level language looks like. Finally, this language will be converted into a machine level code, and it is going to send us the report. This is how a high level language actually looks like. Okay. Next is language translators. So as I have already said, there is a middleman. This middleman, what does it do? He will translate a language, one language to another language. Like if a person only knows English, he doesn't know Kannada, there will be a translator who translates this his speech in a Kannada and makes the person understand. Same way, this language translator, what does it do? It converts your high level language into a machine dependent code. That is what a language translator is. This performs a translation of high level coding. This performs a translation of high level coding into a machine dependent code. Next is, there are three types of translators. One is assemblers, compilers, and interpreters. One is assemblers, compilers, and interpreters. So how does it do? Here, the source programmer is a thing. It is a high level coding. Okay, through using with the help of assembler or a compiler or an interpreter, it will convert this high level coding with the help of a language translator, whatever we have, assembler, compiler, interpreter, into a object coding. A source coding is nothing but it is your English like statements, and object coding means it is nothing but it is a machine dependent code. This is what a language translators are. Now let us see one by one what is assembly. Okay. So this is a translator which converts the assembly coding into a machine level coding. So what is the assembly coding then? The assembly coding, as I already showed you, as I have already showed you. So this is what we say assembly coding. So what does this assembly coding happens is this assembly coding. So you can see out here. You can see out here, right? So what happens here is here in the inner left part, you are going to see assembly level coding. So with the help of assembler, this assembly level coding will be converted into zero sign ones in which you are going to see in your right side. So this is how assembly level coding works. So assembler is a part or it is a translator which converts your high level language into a machine dependent code. Okay. So the assembler checks for the syntax and schematics for a code to be translated into a machine coding, for the code to be translated into a machine coding. So there are different kinds of assemblers. One is TSAM, turbo assembler, FSAM is flat assembler, and MSAM is Microsoft macro assembler, and net assembler, NSL. Net assembler. So what does it do means these four assemblers also converts the assembly level code into binary fashion or a machine level coding based on the given conditions which we are going to apply for a person. Okay. So now how actually as I already showed you, this here, what does it do means here? So what does it do means here you are going to find a piece of assembly level coding. Okay. Here you're going to find a piece of assembly level coding. This assembler will convert this assembly level coding into a zeros and ones of the called as machine level coding. So this is what an assembler is. What is the assembler then? Assembler is a translator. Assembler is a translator. The assembly level assembly language requires a translation of English-like statements to a machine level coding. The system software assembler will check for a syntax and schematics of a code and translates it into a equivalent machine code and machine code also known as a object code. The following we have different kinds of things. Those are TSAM, FSAM, MSAM, and NASM. Okay, turbo assembler, flat assembler, Microsoft assembler, and NSAM, net assembler. So this is what assembly level coding is. The next is compiler. So what does the compiler do? A compiler will convert your high level language into a machine dependent code. A compiler will convert a high level language into a machine dependent code. Okay. So here what does it do? Here this will check for schematic errors line by line. So whatever the coding I have showed you, whatever the coding I have showed you here, this is a compiled code. And already compiled using a software called as Turbo C++. Okay, this compile code means here a compiler. What does it do means he will check line by line, one line and two line like this, one after the line by line, one after the other. After that, he is going to perform a output operation. After that, he is going to perform a output operation. Okay. This system software translates a source code into a machine dependent code. So how does it translate? The source code ಅಂತ ಹೇಳಿದ್ರೆ, as I will show you, wait. See here. So here what happens is source code has a is equal to hello or b is equal to hello. So what does it do means here, wait a second. So you can see here. So this is the source file which you are going to see in my cursor which is moving on. So here has some of the conditions for what we say a high level language. The compiler converts this condition, checks line by line and converts into zeros and one fashion. Zeros and one fashion. This is how a compiler converts your file. So if you have some of the library files, so so this whatever you're going to see over here, which is bluely marked, right? These are the library files. These library files are being loaded. These library files are being loaded with the help of linkers. So linkers will load these library files, and then it will help you in the form of executable code. Executable code. So this is how a compiler runs. How a compiler runs. What does the compiler is? A compiler is a system software which converts your high-level language into a machine-dependent code. Which converts your high-level language into a machine-dependent code. The last one is interpreter. So what is an interpreter then? An interpreter is a translator which translates the high-level language into immediately executable form. Your compiler ಏನು ಮಾಡುತ್ತೆ ಅಂತ direct ಆಗಿ machine level code convert ಮಾಡುತ್ತೆ. ಇದೇನು ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ ಫಸ್ಟ್ ಇಮಿಡಿಯೇಟ್ಲಿ ಎಕ್ಸಿಕ್ಯೂಟಬಲ್ ಫಾರ್ಮ್ ಅಂತ ಹೇಳಿದ್ರೆ ಯಾವುದೇ ಸಿಸ್ಟಮ್ ಹಾಗೂ ಡೈರೆಕ್ಟ್ ಆಗಿ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗೋ ತರ ಕೋಡ್ ನ ಪ್ರಿಪೇರ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಆಫ್ಟರ್ ದಟ್ ಅಗೇನ್ a compiler converts this immediate execute code into a machine level. So all the systems have the different types of compilers. Okay, each compiler is dependent on what performance it is going to perform. Same way here the interpreter, what does it do mean ಅಂದ್ರೆ ಇದೊಂದು ಈ ಮಿಡಲ್ ಮ್ಯಾನ್ ನ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. ಒಂದು ಮಿಡಲ್ ಪರ್ಸನ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೊಂಡು ಆ ಮಿಡಲ್ ಪರ್ಸನ್ ಇನ್ ಇಮಿಡಿಯೇಟ್ ಫಾರ್ಮ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಯಾವುದೇ ಒಂದು ಸಿಸ್ಟಮ್ ಆ ಇಮಿಡಿಯೇಟ್ ಫಾರ್ಮ್ ಹಾಕಿದ್ರೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಎಕ್ಸಿಕ್ಯೂಟ್ ಆಗಬೇಕು, ಎರಡೆರಡು ಕೆಲಸ ಮಾಡೋದಿಲ್ಲ. ದಟ್ ಈಸ್ ವಾಟ್ ಇಂಟರ್ಪ್ರಿಟರ್ ಇಸ್. Generally compiler runs faster than interpreter because interpreter has two steps. First it should be converted to immediate form, and then you should convert that interpreter into a compiled form. Interpreter immediate form into a compiled form executable code. For this reason compiler runs faster than an interpreter. Okay, the next is the interpreter are something used during a development of a programming. So what is this interpreter? The interpreter yaವಾಗ use ಮಾಡ್ತೀವಿ when a huge program is to be developed. Okay, and which has multiple modules and small sets of programs. Okay, ಆ modules ನ add ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ ನಾವು ಎಲ್ಲಾರನ್ನ ಚೆಕ್ ಮಾಡ್ಕೊಂಡು ಬರೋಕ್ಕಾಗಲ್ಲ. We require a part of the program and we should check that and we should implement them. So at that time we use an interpreter. Interpreters are sometimes used during the development of a program when a programmer wants to add small section at a time and test them quickly. When a proper testing is required, at that time an interpreter is used. An interpreter is a language processor that translates the instruction into a high-level language and immediate executable code before translating to the next instructions of a source code. So for that is what an interpreter is. So you can see I have provided an image here. So here what happens here is, here a interpreter, there is a source code which means that the English like statement, it is being converted into a bytecode. What is this bytecode is, bytecode andre ಯಾವುದೇ ಒಂದು ಸಿಸ್ಟಮ್ ಲೈನಕ್ಸ್ ಆಪರೇಟಿಂಗ್ ಸಿಸ್ಟಮ್ ಆದ್ರೂ ಹಾಕು, ವಿಂಡೋಸ್ ಆಪರೇಟಿಂಗ್ ಸಿಸ್ಟಮ್ ಆದ್ರೂ ಹಾಕು, ಇಲ್ಲ ಮ್ಯಾಕ್ ಆಪರೇಟಿಂಗ್ ಸಿಸ್ಟಮ್ ಆದ್ರೂ ಹಾಕಿದ್ರು ಅದು ಏನ್ ಮಾಡುತ್ತೆ ಅಂತಂದ್ರೆ ದಟ್ ವಿಲ್ ಟೇಕ್ ದಿ ಎಕ್ಸಾಕ್ಟ್ ಟೈಮ್ ಆಫ್ ದಿ ಸಾಫ್ಟ್ವೇರ್. ಅಂದ್ರೆ ಅದೇ ಪ್ರಾಪರ್ ಸಾಫ್ಟ್ವೇರ್ ತಗೊಂಡು ಯಾವುದೇ ಒಂದು ಪ್ಲಾಟ್ಫಾರ್ಮ್ ಹಾಕಿದ್ರು ರನ್ ಆಗುತ್ತೆ. This is what a interpreter is. So this is today's session.